Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 990, Satisfiability of Equality Equations. This is a medium level difficulty graph problem, and the hardest part of this problem is actually figuring out that this is a graph problem. So we're told that we're given an array of strings called equations, which each represents a relationship between variables, where each string is a string of length 4 and it takes two forms. One is x equals y, and the other one is x does not equal y, and x and y are lowercase letters that represent one letter variable names. So these are going to be our vertices x and y. And we return true if it's possible to assign integers to variable names so as to satisfy all the given equations, or false otherwise. So in this example, we have a equals b, and b does not equal a. So the output is false because these equations don't satisfy each other. How can a be equal to b, but also b does not equal to a? So we return false. In the second example, b is equal to a and a is equal to b. These both satisfy each other, so we return true. So why is this a graph problem? Well, look at how we can solve this problem. Well, if we have x and y, let's say we have three vertices. We have a. Well, actually, let's look at. Let's say we've got three conditions. So we have a equals b. Let's say we have b equals c, and then let's say finally we have a does not equal to c. Okay, so we have three conditions over here: a equals b, b equals c, a does not equal to c. So what if we just take these two conditions over here, so a equals b and b equal to c, and put them into a graph? So we'll get a, and we'll get a connected to b, and let's say b connected to c. So that's our graph right here. And how would we would test that all equations are satisfied? Well, we can do that by saying, can we a is equal to b, b is equal to c. Okay, so we'll create our graph, and then we look at all the inequality equations. So a does not equal to c, and we look through our graph, and we'll know that this condition is not satisfied if we can't get from a to c. If we can get from a to c, that this means that this equation is not satisfied. Or so if we can get from a to c, this means that this equation is not satisfied. If we can't, then it means it is satisfied. So if we can we go from a to b? Yes, we can. And then from b to c, can we go from b to c? Yes, we also can do that. So this equation is not satisfied, and therefore we return false. So that's the theory behind solving this problem. How can we solve this problem? Well, we can first create our graph, which is step 1, and step 2 is going to be actually doing breadth first search. We can do depth first search or breadth first search, but it's going through the graph and saying, can we go from one node to the other node? Can we go from x to y or from a to b? So let's actually hop into building our adjacency list. So we're going to create our adjacency list, which is going to represent our graph. We'll set it to a default dictionary of list, as we always do. And we're going to say for each equation in equations, if equation 1, 2, 3 is equal to an equal sign, well, this equation we're going to map to our graph. So we're going to say a and b is equal to equation 0 and equation 3. And we're going to say, well, what we're going to say, we're going to just say, let's append these things to these nodes to our adjacency list. So a dot append b and adjacency list b dot append a. This is a undirected graph that we're building. So what can we do now? Well, the first part is step 1, building. What did we say? We were building our adjacency list, or building our equality graph, so to speak. And then step 2, checking all the equations are satisfiable. So how can we do this? We can say for each equation in equations, Now, if this equation is equal to an inequality operator, we only want to check inequality equation. So I'm going to say, we can just copy this actually. So we're going to copy all this is equal to does not equal to. Well, what can we do now? Well, before we do breadth first search, let's actually check a simple condition, and that is if A does not equal to A. Well, we don't need to do any breadth first search. We know this condition it's not valid, so we can just check for this condition first. So we're just going to say if A equals B. So if the node if A equals B, we can just return false. So this checks that edge condition. Otherwise, we're going to do breadth first search because we've got a diversity graph. Of course, we need a set. So we're going to have a set. We're going to also have our queue. Our queue is going to initially just take A, and we're going to say while queue node is going to be equal to q.pop0, q.pop0. And now what we're going to do is we're going to say if node is equal to B. So if the node we have is equal to B, then we return false. We should not be able to get from A to B. That should not happen. Otherwise, we're going to say for each neighbor in adjacency list, and we'll pass in our node. So for each neighbor, we're going to say if the neighbor is not in our visited set, then we can add it to our visited set, of course, visited.add neighbor. And we can also say, let's add you to our queue, so queue.append neighbor. And if we finish this if we finish step 3 and we don't return false, well, then we return true. It just means that all equations are satisfiable. So let's run our code. And we pass all test cases. So I hope you guys enjoyed this video. It is a bit of a confusing one because in this video, I basically just skipped straight telling you guys that this is a graph problem, but that does take a while to figure out, and it's not the only way we can do it, but it is the most optimal way. We could also use a union find, or you can not do graphs at all, and not implement any graph theory. You can do just iterate and do a couple of loops to solve this problem by substituting in numbers. Would it be the most efficient solution? Probably not, but it will also work. So with that being said, I hope you guys enjoy this video, and I'll catch you in the next one.